Okay, if you've made it this far, you understand what surds are and how to simplify them, how to multiply them, how to divide them, how to add them and subtract them. Now we're going to look at something called rationalizing the denominator. Is when you have a surd and you want to get rid of that surd. Rationalizing is getting rid of the surd. So on the bottom denominator of a fraction, if it's a surd, we want to get rid of the surd on the bottom. That's what rationalizing is, getting rid of the irrational component. So in the expression 2 on root 3 plus root 3 on 2, the first term has a square root in the denominator. This makes it difficult to tell if they're like surds or not. Fractions involving surds are easy to deal with when the surd is in the numerator and there is a whole number in the denominator. To express a fraction in such a way is called rationalizing the denominator. So we're getting rid of the irrational part on the bottom. We're rationalizing the bottom. When you want to rationalize the denominator, when you've got just a single term, all you've got to do, I've got 1 on root 3. I don't want to change this in any way, so I have to multiply it by root 3 on root 3. The reason being, anything divided by itself is just 1. So basically what I'm doing here is I'm just multiplying 1 on root 3 by 1. If we multiply anything by 1, we haven't changed it, so we're just getting it in a different format. If you notice, on top, if I go 1 times root 3, outside I've got a 1 and a 1, so I just get 1. And then inside I've got nothing here to be a root 1 and root 3. So on top, that ends up being root 3, because 1 times root 3 is just root 3. On the bottom, I've got root 3 times root 3, which we know is root 9. That's also root 3 on the square root of 9 is 3. So if you want to, you can skip that step. You can go 1 on root 3 times times root 3 on root 3. On top, we get root 3. On the bottom, root 3 times root 3 is 3. And that's it rationalized. So we now no longer have a square root on the bottom. The bottom is now rational, i.e. we've rationalized the denominator. Okay, so rationalize the denominator of the following. Now, when you've got two values on the bottom, so if I've got something outside the radical and something inside the radical, all you need to do is multiply it by whatever's under the radical. So 2 root 5 times root 5 on root 5. On top, I get 4 root 5, because there's nothing else outside, so that just remains 4, and there's nothing else under the square root. Underneath, I get 2 times root 5 times root 5 is 5, so I end up with 10. Then we have a look and we go, okay, we can simplify the top and the bottom. 2 goes into that twice and into that 5 times, so I get 2 root 5 on 5. Now you might say, why don't we multiply it by 2 root 5 on 2 root 5? I'll show you here. If I had 4 on 2 root 5 times root 5, 2 root 5 on 2 root 5, on the top we're going to get 8 root 5, on the bottom we're going to get 2 times 2, which is 4, and then times root 5 times root 5, which is 5. 4 5s are 20. We just have to simplify. You'll get exactly the same answer, but we've got to go, okay, what can I simplify? 8 on 20, 4 goes into both of them, goes into the top twice and into the bottom 5 times. We end up with the same answer. But all we're doing, when we multiply it by 2 over 2, we're just adding something in that we have to simplify at the end. Sometimes you won't have to simplify top and bottom. But if you do this, you will always have to simplify top and bottom. So when it's just one term, on the bottom, you just multiply it by whatever's under the square root. So in this case here, we would say 4 root 3 minus 1 on 4 root 6, multiply it by root 6 on root 6. On top, I'm going to get 4 root 18, because root 3 times root 6 is root 18, minus 1 times root 6 is root 6. On the bottom, we've got 4, and then root 6 times root 6 is 6, so 4 times 6 is 24. Okay, then on top, we've got 4, 9 times 2, 4 root 9 times 2, minus root 6 on 24. 4 times 9, root 9 is 4 times 3, which is 12, root 2, minus root 6 on 24. Now, a common mistake that students make is they simplify this, and they say, okay, 12 goes into itself once, and it goes into 24 twice. You can't do that, because if you simplify any fraction, on top, I had 12 root 2 minus root 6 on 24. If you ever want to simplify a fraction, you have to be able to take it out from the top as a common factor. Now, 12 isn't out the front of this, so it's not a common factor. So we can't simplify this anymore. We leave it just like that. You can't do anything with it. Okay, so in this case here, our first term, that's got a square root. This one doesn't. So what we're going to do is we're going to work with them separately. So I say 2 on root 3 times root 3 on root 3 plus root 3 on 2. We don't need to rationalize the denominator on this second bit, so we just leave it alone. Over here, I've got on top, I'm going to have 2 root 3. On the bottom, I'm going to have root 3 times root 3, which is 3, plus root 3 on 2. Now, we know with fractions, we can't add unless they have the same denominator. So I want to work out something that 3 and 2 both go into. In this case, it is 6. So if I make the bottom a 6, I've multiplied it by 2. I've got to do the same to the top, and I get 4 root 3. Here, if I make the bottom a 6, I've got to multiply the top by 3, because that's what I've done to the bottom. So in this case here, I've got 4 root 3 plus 3 root 3, which we know is 7 root 3, on the common denominator of 6. So that is our solution. We can't simplify. There's nothing that goes into 7 or 6 that'll simplify, and you can't simplify root 3. Okay, binomial denominators. This is when you don't only have one term on the bottom, you have 2. Okay, so here in the expression 1 on root 7 minus root 5, it's more difficult to remove the surds from the denominator. However, we've learnt a little trick. Difference of 2 squares allows us to get rid of the square root in any term. If we multiply something by, we'll call it its conjugate, where we change the sign in the middle, then we'll end up with a difference of 2 squares, and we'll end up getting rid of the square roots. So it's easier for us. Now, with before, when I only had one term, I didn't have to worry about multiplying it by that number out the front. But when you've got 2 terms, binomial, we need to multiply it by, so I go 2 root 5 on 2 root 5 minus 2. Now, to get rid of our irrational, our surds on the bottom, we've got to multiply it by exactly the same thing, but we change the sign of the middle term. So here I go 2 root 5 plus 2 on 2 root 5 plus 2. Now you can see here 2 root 5 plus 2 on 2 root 5 plus 2 is that's just 1. So we haven't changed anything. Okay, now we know that we can multiply the top by the top. So I have 2 root 5 times 2 root 5, which is 4 times 5, which is 20. Use the distributive law, we multiply this by this, so I get plus 2 root 5 times 2 is 4 root 5. On the bottom, we've got a difference of 2 squares, because we've got 2 root 5 minus 2, 2 root 5 plus 2. We set this up deliberately, because we know it'll get rid of our middle term. So we know when we've got a difference of 2 squares, it's the first term squared, so 2 root 5 squared, minus, because the rule says minus, and then 2 squared. So in this case, we've got 20 plus 4 root 5 on 2 root 5 squared is 4 times 5, which is 20, and then minus 2 squared, which is 4. So we end up with 20 plus 4 root 5 on 16. Now, are we finished there? No, we're not. This is what I was talking about before. We can take out a common factor on top of 4. So if I take out a 4, I'm left with 5 plus root 5 on 16. And then from here, we can divide 4, because it's common to both of them. If we divide the top by 4 and the bottom by 4, we end up with 5 plus root 5 on 4. Now, have we done what we wanted to? Have we rationalized the denominator? Do I have any irrational things on the bottom? No. No irrational. So it has been rationalized. And we've simplified it as much as we can. We can't do anything else with that. Okay, I'm just going to draw a line down here so we can separate the two. Okay, so here I've got root 3 plus root 2 on 3 root 2 plus 2 root 3. Now remember, we want to multiply it by the conjugate of this, where we change the sign in the middle. So I'm going to say 3 root 2 minus 2 root 3 over 3 root 2 minus 2 root 3. Of course, we know that that's 1, because anything divided by itself is 1. Okay, from here, we've got to use binomial expansion. So, let's have a look. I've got root 3 times 3 root 2, which is 3 root 6. I've got root 3 times minus 2 root 3. So that's going to be minus 2 times root 3, which is minus 2 times 3, which is minus 6. Then I've got my inside terms. So I've got root 2 times 3 root 2, which is the same as 3 times 2, or plus 6. And then I've got my last terms, which is going to give me minus 2, and then under the square root, I've got root 6. On the bottom, we've got a difference of 2 squares. So we've got 3 root 2 squared minus 2 root 3 squared. Because it's a difference of 2 squares, we know we can just do that. Here, I've got minus 6 and plus 6. They're going to cancel each other out. I've got 3 root 6 minus 2 root 6, which is just root 6, 1 root 6. On the bottom, we've got 3 squared times root 2 squared, which is 9 times 2, which is 18, minus 2 squared, which is 4, times root 3 squared, which is 3. 4 3s are 12. So we end up with root 6 on 6. We can't simplify that anymore, so because 6 doesn't have any perfect squares that go into it, so we end up with root 6 on 6. And that's as simple as we can get, and we've rationalized the denominator. There's no irrational denominator. There's no irrational denominator anymore. Okay, so here, to rationalize the denominator, we multiply 2 on root 3. We multiply it by root 3, the top and bottom by root 3. So if I had 2 root a, if I had, just to do it in general terms, if I had 1 on 2 root a, we'd multiply that by root a on root a, because all we want to do is get rid of what's under the square root. The 2 doesn't affect that. When we have something like 3 on 5 plus 2 root a, we multiply it by the same thing, 5 minus 2 root a, but we change the sign in the middle, 5 minus 2 root a, and that ends up giving us a difference of 2 squares, so we get rid of the irrational denominator. So that's why it's called rationalizing the denominator. Rationalizing the denominator allows us to identify like and unlike surds, so we can just add them together easily because they have the same square root and it's on the numerator. We've just got to get a common denominator on the bottom. Okay. We've got an idea of how to rationalize the denominator now. You've just got to remember 1 on root A, multiply it by root A on root A, 1 on, or anything on 5 root A, we still just multiply it by root A on root A. And if we have something like 1 on 3 root A plus root B, we've got to times that by, this time we've got to keep all of the terms, so 3 root A, oops, it's not an A, that's a 3. 3 root A minus, because we changed the sign. So if it was a minus, this would be a plus, but because it's a plus, this is a minus. Root B on 3 root A minus root B, and then we expand it like binomial terms. On the bottom, this will get rid of the surd, i.e. rationalize the surd. Okay, good luck with that. Hopefully you understand and you can finish off the exercise.